Okay, so they have given us basically the angular velocity, but we need to convert it to radians per second, not revolutions per minute. So go ahead, divide 60 seconds to get the minutes to seconds and the revolutions into radians. Come out with 22 radians per second. Now that is the angular velocity. Okay. Now, since we got the angular velocity, I went ahead and used this equation because they want to know what the angular acceleration is, which is alpha. I manipulated it. This is what I get. So I just divided 22 by 0.75 seconds, and that is the 29 radians per second squared. Now that was part A. Okay, now part B, since they want the revolutions, I went ahead and used this equation because we know what the final and initial angular velocities are, and we know what the time is. Now we don't know what the unknown variable is, okay, and that can stand for revolution. So I went ahead and we know what the initial angular velocity is 0 because they said it rotates from rest. So that's plus 0. I just didn't include it, but that's what it really is. So I went ahead and multiplied them both like the equation said. Seconds cancel out, get 8.25 radians. Then you just convert that into revolutions. Divided it by 2 pi, 1.3 revolutions. That is part B. Now part C, they actually want the accelerations of tangential and radial accelerations. Okay, they wanted those components. So because of that, and it was specifically rotating 180 per minute, okay, at 0.12 meters, which is the radius. So because of that, well, first thing we got to do is we have to convert this into the proper units, radians per second. So I went ahead and did that, and this is what I got. 18.8 radians per second, which is the angular velocity. Now since I have that, now I know the velocity. Well, this is the radial component of the acceleration. And we know everything except the radial component. So because of that, you just square the 18.8 and you multiply it by 0.12. So that's the radial acceleration, 42 meters per second squared. Now the tangential would be this, alpha times radius. Okay, so now I went ahead and used the 29 because that's the angular acceleration that I found earlier. Okay, it's constant, so we can use this one, 29. So I went ahead and multiplied by this, the radius, and this is the tangential component.